Glad to see you've all tuned in to learn a little bit about pressure and wind and the relationship between the two. So starting, just to talk a little bit about wind, sometimes you may hear westerly wind, easterly wind. Anytime we are naming winds, we're going to name them from the direction from which they come. So if we say we have a westerly wind, we mean that the wind is actually moving from the west to the east. Moving on, what causes wind? So this is a major concept that will be very important to understand in order to be successful in this unit. Wind is caused by differences in air pressure. So again, air is going to move from areas that have high pressure to areas of low pressure. You can think of it like a balloon. If you blow air into a balloon and fill the balloon, you're going to create an area of a higher pressure within the balloon because you're going to be forcing air molecules into the balloon. If you don't tie the balloon and you're just holding it and you release, the air is going to want to escape from inside the balloon where you have the high pressure to the areas of low pressure, which would be the room on the outside of the balloon. So again, a major important information to know that air is always going to move from high pressure to low pressure. Now, sometimes you may see something called a pressure gradient. So if you see the words pressure gradient, what that's referring to is the amount of difference between two areas. So one area may have high pressure, one area may have low pressure. The difference in those pressure readings is going to be your pressure gradient. Areas that have a steep pressure gradient or a bigger difference in the two areas, air pressure is going to have a greater wind velocity. So, for example, on the top, I want to show you here, you can see in one area there is an air pressure reading of 1,008 millibars. Over here on the other side, it is 992 millibars. This area has a greater difference between 1,008 and 992 than my gentle pressure gradient here. So, for example, the difference between these two numbers, 1,008 and 992, would be 16 millibars. The difference between point C and D would be 8. So the area between A and B would have a greater wind velocity. So you would see windier conditions between A and B. Now, how do we measure air pressure? You will never probably be tested on this, but it's important to know that what you see on the news and how we report in science may be slightly different. It's kind of like how sometimes you measure temperature in Fahrenheit or Celsius. There are two different ways that we can measure air pressure. Often on the news, if you're watching a weather report, they're going to give you inches of mercury. In science or weather maps, often if you're looking, you will see that it's measured in numbers that look more like this, in the 900 to 1,000 range. This is millibars. So if you look here on the right-hand side, and I apologize, I have my grandfather clock going off in the background. We have areas that are measuring your inches of mercury, and they're coordinating millibars on the left. Keeping it moving, this should be a review because you should have all kind of had a little bit of background with convection currents. But wind always, again, bing, important, moves from areas of high pressure to areas of low pressure. Again, this is showing a convection cell within a room. In this room, we have a fireplace. And the fireplace is creating heat. The heat causes the molecules to expand, becoming less dense. The hot air rises, but that hot air is going to be pulled across the room towards the cold area. And as it moves across the room towards the colder area, the molecules will then shrink back in together, creating more density, higher pressure. It will fall towards the ground because the molecules are more dense, have higher air pressure, and then they will again, those areas of high pressure will move to low pressure. This is exactly what you would have seen within class and labs and other activities. Now, again, a review because this is a major concept we're pulling away from the unit. Cold air is more dense. The molecules are tightly compacted. When I'm chilly, I want to snuggle up. I want to get warmer. But in this case, the molecules get close together. Warm. Think about when you're in gym class. If you're coming back, the molecules, you don't want anybody to be right on top of you. These molecules have more energy. Therefore, they are spread out further apart and become less dense. Remember, less dense means lower pressure. More density means higher pressure. Here's just a quick, this was animated, but you can just see right here that I filled this in for you. In a high pressure area, air will always sink because the air is more dense. This is because cold air always sinks. Therefore, clouds cannot form. High pressure means a clear blue sky, no clouds. High pressure means there's not room for those water molecules to fit within the air. So, high pressure means a clear blue sky. Clouds cannot form because the molecules are closer together. Just in the, likewise, a low pressure area, the air is going to rise because the air is less dense. This is because warm air rises. In warm conditions, clouds are more likely to form. Low pressure will make you go inside your house all day because rain and clouds are coming our way. Important, important, important to know. Okay, correctly draw the direction of wind flow in both the high and low pressure area in the northern hemisphere. So on the diagram on the left, you will see that it's low pressure system. The air molecules and wind flow will move in a counterclockwise pattern towards the center of the system. A low pressure system is going to be rain, clouds, stormy weather. A hurricane is a low pressure system, a large low pressure system. But just remember, in those systems, it's going to move in a counterclockwise pattern towards the center of the storm. Likewise, on the right, you have a high pressure system. Wind is going to flow away, remember, moves from area of high pressure to areas of low pressure. It's going to move away from the center, away from the high pressure in a clockwise pattern. Excellent. Now, this is a chart. This is an important chart. It's going to show the difference between low pressure and high pressure. I would suggest pausing here and making sure you get all this information recorded. It's exactly what I just told you in the last. You may also want to include the diagram that was previously outlined. Okay, so we're going to start talking a little bit about wind and being near the ocean and shores. So what's the relationship between wind and waves? Is there a relationship? And of course there is. There's a direct relationship. The stronger the velocity or the speed of the wind, the larger the waves are going to be. That's a pretty simple concept. You know, really, really windy days where wind is coming off the ocean, of course, that's when you're going to produce those larger waves. I wanted to show this for a moment. This is showing the convection cells and the movement of wind on a global pattern. So you can see the rising and falling in air, these circular patterns within the atmosphere, the troposphere, that are going around. Those are showing the different convection cells. In addition, you can start to see little X's throughout. Those are the jet streams. So you have subtropical, you have polar jet streams. Within that, they're also showing you the diagram looking straight on where you can see the movement of those currents, or those convection currents throughout the atmosphere. Okay, moving on. Land breezes and sea breezes. We are going to come back and hit this in a moment. I just wanted to stop here to give you guys an opportunity. This is it for today. Appreciate it so much.